Hello student, I am Dr. Anamika Goyal from ABES Engineering College, Ghaziabad. Today I am going to discuss about the topic Algebraic Computations of Unit 5th of the subject Design and Analysis of Algorithm. In this topic, I am going to discuss about first the introductions of algebraic computations. After that, we'll discuss key areas of algebraic computations, that is matrix operations and polynomial operation. Then we'll discuss the techniques used in algebraic computation, and last we'll discuss the matrix operations using Strassen's multiplications. So let's start our topic. First one is the introductions to algebraic computations. Basically algebraic computations it provide the mathematical tools needed to describe, analyze, and optimize algorithm, especially in areas involving efficiency, correctness, and scalability. Or we can say algebraic computation, it is a scientific area that refer to the study and development of algorithm and software for manipulating mathematical expressions and other mathematical objects. So basically, algebraic computations when we design an efficient algorithm to find solutions of a given problem using some concept of some algebraic concept like matrix and polynomial, so these kinds of concepts comes in the categories of algebraic computations. Next, we'll discuss the key areas of algebraic computations. The import basically the two operation these two operations demonstrate how algebraic computations optimize the complex operations for real world application. The two most important algebraic computations key areas are, first one is the matrix operations and second one is the polynomial operation. So if I'm talking about the matrix operation, if I'm talking about the matrix operation, conventional matrix operation, so we all know in case of conventional matrix operation, we are just given a matrix A. Suppose the matrix A, B, C, D, whose dimension is 2 by 2, and another matrix B, whose dimensions again 2 by 2, A1, B1, C1 or D1. If I want to compute the multiplication of these two matrices, C is equals to A by B. So in that, which is again the 2 by 2 size matrix. So in that case, the conventional approach will take or time order of n cube time for the computations of matrix multiplication using a standard or conventional matrix multiplication approach. With the help of doing some algebraic computations, efficient matrix multiplication techniques such as Strassen's algorithm significantly reduce this computational time complexity order of n cube to order of n raised to the power 2.81, right? Similarly, if I want to discuss about the polynomial operation, so when we want to solve any polynomial equations using a naive approach, like the polynomial equations px is equals to a0 plus a1 x raised to the power 1 plus a2 x square plus a3 x cube up to an x to the power n. If I want to compute the polynomial expressions using the naive approach, the time complexity here is order of n square. So with the help of suitable algebraic computations, that is fast Fourier transform, we can reduce these time complexity order of n square to order of n log n. So that is the basic applications of algebraic computations. So these are the two important key areas of algebraic computations basically used to reduce the time complexity of naive approach to using algebraic computations. Now we discuss the technique used in algebraic computations. Basically, the techniques used for the algebraic computation is divide and conquer approach. We also use the dynamic approach, or we can say the recurrence relations approach for algebraic computation, but the mostly used approach is divide and conquer approach. Like for the matrix operation, Strassen's algorithm use Strassen algorithm basically divide the matrix into number of blocks. For the polynomial operation, we use fast Fourier transform. This technique split the polynomial multiplication into a smaller subproblem. So today lecture we just discuss about the matrix operations for algebraic computations. For and the polynomial operation we'll discuss in our next upcoming lecture. So today we'll discuss only matrix operations. So first we'll discuss matrix operation using divide and conquer approach. So in divide and conquer approach, suppose we wish to compute the product C is equals to A into B, where A, B and C are n by n matrix. So in divide and conquer approach, the mandatory condition is n is an exact power of 2. Suppose if I want to multiply two matrix A and B using divide and conquer approach. So first of all, we just check that the matrix dimension is in exact power of 2 or not. And after that, we divide each of A, B and C into n by 2 n matrix, and then rewriting the equation in the form of C is equals to AB. Here C represents the solution matrix and this one is the A matrix and this is the B matrix. We solve these A into B matrix recursively. Basically, in divide and conquer approach, first we'll divide our problem into n by 2 matrix. After that, we'll conquer means we solve these smaller subproblem recursively, and then we'll combine all the subproblem solution into a single problem, single solution. So now now we'll discuss how we can compute this matrix C is equals to A into B. So you can see here, if we want to compute the value of R, so what we have to do, we just multiply the row of first matrix into the column of second matrix. So the value of R is equals to A multiplied by E plus B multiplied by G. Similarly, the computations of S is A multiplied by F plus B multiplied by H. Similarly, we can compute the value of T and value of U. So if you see this equation carefully, so in that case, we use 8 multiplications and 4 additions operations for the multiplications of two matrix, right? You just check it. First multiplication A into E, here this is again a subproblem whose size is n by 2. Second multiplication B into G, again subproblem, the size is n by 2. Similarly AF, PH, CE, DG, CF, DH. So total multiplication is 8 multiplication and the size of each multiplication is n by 2. And we use 1, 2, 3, 4. 4 addition, right? 4 addition. And the cost of matrix addition in the cost of matrix additions is order of n square, right? So if we writing the recurrence equations of divide and conquer approach using matrix multiplication is, so this is T of n is equals to 8Tn by 2. This is the cost of 8 multiplication and the cost of addition is order of n square. So the recurrence equation is T of n is equals to 8Tn by 2 plus order of n square. If we want to, if we'll solve these equations using master method, so the time complexity in that case is order of n square. Strassen's will reduce this time complexity order of n cube is using some algebraic calculations, basically additions and multiplication operation, and will reduce this time complexity order of n cube to order of n raised to the power 2.81. So we'll discuss this. We'll discuss the Strassen's approach here. This is basically the Strassen's multiplication approach of matrix operation. So Strassen first split the problem into n by 2 n by 2 size. So Strassen basically use the extended form of divide and conquer approach. The step number 1 is divide the problem. First step, Strassen divide the n by size problem into n by 2 n by 2 matrix. After that, in concur step number 2, Strassen use 7 intermediate product M1 to M7. That is the recursive approach. That is concur approach, right? Recursively find out the solution of 7 intermediate product, and this one is the divide step, right? So in that case, stations use some algebraic equation like if station first compute the value of M1 using A11 plus A22 into B11 plus B22. Then will compute M2 A21 plus A22 multiply by B1. Similarly, will compute M3, M4, M5, M6, M7. So this is the concur step. So first will divide n by size problem into n by 2 and then will compute 7 intermediate product. If you see this intermediate product carefully, so you here you found that Strassen will use only 7 multiplications operations apart from 8. First operation 1, then 2, then 3 multiplication, then 4 multiplication, then 5 multiplication, 6 and 7. In this case, Strassen will use only 7 multiplications operations and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 9, 10 and wait for a minute. 11, 12, 13, 14, 15, 16, 17, 18. So if you can see these equations carefully, so according to Strassen's divide and conquer matrix operations approach, Strassen will use 7 multiplications operations and 18 additions or subtractions operations. So Strassen will combine these 7 products to compute the submatrix of C, that is C11, C12, C21 and C22. This is our final product matrix. And to generate this product matrix, Strassen use 7 multiplication operation and 18 addition or subtraction operation. And we know the addition and subtraction operation will take order of n square time for the computations, and the cost of multiplication where each multiplication size is n by 2, right? So if we analyze, right, if we write to the recurrence relations of this Strassen multiplication, so it will be 70 n by 2 70 n by 2 plus order of n square. If we want to if we will solve this equation using master method, so again the time complexity is order of n raised to the power 2.81. So if you see the matrix multiplication using divide and conquer conventional approach, the time complexity of is order of n cube, which will reduce using the algebraic computation is order of n raised to the power 2.81, which is 0.19 times better than previous approach. So this is the basic applications of algebraic computations. I hope you understand the concept of algebraic computations. In my next lecture, we'll discuss polynomial operation in detail. These are the references used in our presentations. Thank you.